In this video, we are going to simplify the division of two rational expressions. So we have a rational expression divided by another one here. Now, some ideas, a quick review. If you are dividing a fraction a over b by c over d, what you do is you change the division into a multiplication by the reciprocal of the second fraction. Exactly the same thing can be done with rational expressions. So we go here and we rewrite the expressions. Now this division, I'm going to change it into multiplication. And here I take the reciprocal of this, meaning that you flip the denominator and numerator. So the denominator becomes numerator and the numerator becomes denominator. So a division becomes a multiplication, as simple as this. The second idea we're going to use is this. If you have a factored form of a polynomial in the numerator and the factored form here, if there are any common factors, you can simplify or cancel. Now, before we do this, of course, we need to factor these expressions. However, let's have a look exactly what we have. Now, we can see that here in these polynomials, all the coefficient and the constant are even numbers. The same thing here. So 2 can be factored out in both here and here, in this expression and this expression. So let's factor them out. Rewrite x2 plus x minus 2, x2 plus 8x plus 15 here, multiply. Now there is nothing to factor here, so we rewrite it again. Now here we have 2, 6, so we can factor the 2 out. Plus 2. Okay, good. Now, we have 2 here and 2 here. These, they will cancel because all these are multiplications and divisions only. Good. Now, we need to factor these expressions if possible, of course. So let's start to look at them one by one. Let's look at this one here. x2 plus x minus 2. Can it be factored? Let's see very quickly. X and x. So x by x, x2. I need two numbers. When I multiply them, they give me minus 2. When I add them, plus 1. So it looks like a plus 2 and negative 1, minus 1. So 2 by 1 minus 2, 2x minus x, and then x2. Good. So this is 1. The second one, let's look at the x2 plus 8x. So x2 plus 8x plus 15. Now this will be factored as x here and x here. I need two numbers. When I multiply them, they give me 15. When I add them, they give me 8. It looks like a 3 and 5. So, and both of them plus, because there is a plus here and a plus here. So let's check again. x2, 3x, and hang on, 5 here, we said 3 and 5. So let's start again. So x2, it's here, 3x and 5x, that gives me my 8x, and 3 times 5, 15. Yeah, it's always a good idea to check your factoring, because a small mistake here will be a problem later on. Number 3, let's look at this expression here. It's x2 plus 10x plus 21. So factoring, if possible. I need two numbers. This is 21. I need two numbers. When I add them, when I multiply them, 21. When I add them, 10. So it looks like a 3 and 7. 3 times 7, 21. 3 plus 7, 10. And both of them plus, of course. A quick check, x2. 3x. 7 here. 3x and 7x give me my 10x. And then 3 times 7, 21. Good. Now let's go to this one, the last one. So number 4, we are going to factor this if possible. It's x2 plus 3x plus 2. I'm looking for two numbers. When I add them, they give me 2. When I multiply them, they give when I multiply them, they give me 2. When I add them, they give me 3. And here it's very simple. It's 1 and 2 with the plus, of course, because we have got plus and the plus here. So plus 1, plus 2. Quick check. x2, and then x plus 2x, my 3x, and then 1 times 2. So everything is factored. Now let's go and rewrite everything with the factors. Okay, so the first one here, x2 minus x minus 2, we did it here, so it's x plus 2, x minus 1. The denominator, it's here, it's x plus 3, x plus 5. This is all for the first, the one on the left. Now let's go here, x2 plus 2x plus 21, and this is x plus 3 multiplied by x plus 7. And then the last one, x2 plus 3x plus 2, it's x plus 1 multiplied by x plus 2. Now notice that we have multiplications only and divisions, so we can simplify. If we had the plus here, for example, we cannot simplify. Now, what do we do? What do we have? We have x plus 2 and then x plus 2. These, they cancel. They cancel, meaning that if you divide the top and bottom by x plus 2, they will go. What else do we have? We have x plus 3 here and x plus 3 here. Do we have something else? No. X minus 1, x plus 7. So the final answer is x minus 1 multiply x plus 7. Here in the denominator, we will have x plus 5, x plus 1. No more simplifications, and this is the final answer. This is the expression given above. All this one here in simplified form. So the main ideas here are: rewrite the division as a multiplication, factor the terms if possible, and then divide or cancel as we say.